This is a Sunbeam super heavy duty battery. It's an older battery. I bought 4 of these at the dollar store for $1, and we're going to open it up and take it apart to see what's in there, and also especially to get the carbon rod that's going right through the center of this battery. The first thing you need to do, and it depends on the battery, but this one has a relatively cheap plastic coating on it, and you need to get that off. So I'm sticking a paring knife in there to start ripping that off. Unlike lithium batteries, which you have to be so careful if you touch the positive and negative because they tend to burn right away, these are safe in that regard. So you can dig and cut without any fear. And so here's the battery underneath that branding there. The bottom comes off right away. It's just a thin piece of metal. This is entirely zinc. This is solid zinc, the housing. So you want to save that when you're done because you can use zinc in other experiments. Because zinc is relatively soft as far as the metal goes, you can use a pair of wire snips, wire cutters, and you want to start at the top here and just slowly but surely pull some of it off, and it will tear as you do that. So I just grabbed it with the end, and you can see right here what's going on. I'm just tearing the top of the zinc housing right off, and it'll tear pretty straight. It's kind of nice actually. You don't really have to do anything special about this. So I'm going to keep doing this here, and voila, we've got that zinc, at least the top of the housing, torn off. So the inside of the battery is really put together as one piece, and then it slid into this zinc housing. So I'm gonna start here and slowly but surely pull, and what do you know, right there we've got our carbon rod. Set that aside. Now we got to get the rest of this out of here, and that just requires some more tearing. You can also Dremel this, which is easy. I'm going to keep working on this off camera. So you can see here I just kept pulling and pulling and unwrapping it from the top down. Again, this is pure zinc. You got to clean it a little bit. There's some stuff stuck to there, some electrolyte, but once you do clean it with soap and water, it's pure zinc. And look at this, I can even tear this with my hands. Anyways, so then you can usually pull this top part out here, and the paper here is a separator from the inside material and the zinc, and it's also soaked with an electrolyte. Usually it's ammonium chloride. I don't know 100% what's in here, but you can clearly see once you open that paper up, there's all this black gunk in here. Very crumbly, very messy. I'm going to set it down here. That's manganese dioxide. Getting back to that carbon rod, it's stuck into the positive end here, and usually just some twisting. It's in there with some adhesive, but it's not really. There we go. Came right out actually. So in conclusion, for a mere 25 cents, you can get zinc, pure zinc. I opened 2 batteries because I wanted 2 carbon rods, so this would actually be 50 cents, but still, the zinc, the carbon rods, which you can use for other experiments and especially electrolysis, and the manganese dioxide, which we'll use in a later video. Not a bad deal. So on the left, you can see the 2 carbon rods we pulled out of those AA batteries, but it's in the form of graphite. And so are the 2 pencil leads on the right, something we're all very familiar with. They're not very strong, mechanically speaking, but they are non-toxic, and that makes it good for people who chew on the ends of their pencils, I guess. There's a high melting point of 3,600 degrees Celsius, which is 6,512 degrees Fahrenheit. The thing is, at that temperature, it doesn't actually melt, it sublimes. This is one of those few items that when it gets hot enough, it doesn't melt, it just turns into a vapor. And we're going to use that fact to try to create light with these carbon rods. So in the 1800s, the carbon arc lamp was the #1 way that light was produced. And a typical carbon arc lamp would not last more than a couple hours, for the simple reason that the carbon would eventually break down from the heat. The rods would. They weren't that thick, and they would break down. But what I have here are 2 pencil quote-unquote leads, which is, of course isn't lead, it's graphite. And I'm going to touch the ends of these. I have 12 volts here. I have 8 1.5 volt batteries. They're D-sized connected in series. And let's go ahead and do that here, and we will see we definitely can produce light. It's not terribly bright, but it's definitely light. Next, we have the graphite and or carbon rods we dug out of those AA batteries, and I'm going to touch those together using the same voltage as the pencil leads. And you can see, yeah, that's not nearly enough power. You get a few sparks, that's typical. Be the same as if I tap these together. So we need some more power. Okay, to make our carbon arc lamp work, I pulled out what I have as the most powerful electrical generator, and that, of course, is a microwave oven transformer. Again, but I also want to say again that please don't mess with these if you don't know what you're doing or know how they work or how to do it safely. All right, so I'm going to use my welding goggles here. I expect this to be extremely bright, and I'm also going to be putting on some gloves to be safe. Now, the idea here is not to touch the two rods together like we did with the pencil leads, and they just kind of heated up and produce light. We want an arc. Okay, the transformer is on. And get this set up here. Okay. Get these in view. All right, here we go. Well, you saw a little bit there, but obviously blew a fuse. So here we go. Well, we got a little bit of one before the fuse blew there. Okay, we're going to do this again here. I do think that I might be running into a problem with the power from my house. And I'm not sure that I'm going to be able to continue holding these without something tripping, either the breaker or the switch here that I have next to me. So, okay, the idea again is not to touch them and hold them, but just to touch them and move them apart. Here we go on the count of 3. 1, 2, 3. All right, well, we got it there for a little bit longer, but that's about it. You notice that what seems like smoke coming off is not smoke per se. It's actually the graphite subliming. We know that carbon doesn't melt. It sublimes at just over 6,000 degrees Fahrenheit, and that's what that is.